Robotics, we learn to code and build robots to build and do the rectangle program.
Nice. Cool. So is that the finish point?
Yep.
Where it started? Hey, good job.
Thank you.
That looks good.
At Smart Kids Robotics, I programmed my robot to drive around my track. Go.
Hey, that was sound activated. That's cool. You added that to the beginning of your program?
Yeah.
Nice work. Hey, cool. Congratulations. Nice work.
Smart Kids Robotics, I made a robot that will go around this desk. Observe.
Is that your program there?
Go!
Started by sound activation, huh?
Mm-hmm.
That's cool.
Z.
Hey, nice work. Good job. So what is everybody's first impression of building this robot tonight?
This is my first impression.
Success? Going well?
Slight success.
Okay.
Not
Ashvik, in a word or two, what do you think?
This is very confusing.
It'll get easier as you go, though. What do you think, Yash?
It's hard.
It's hard. I can guarantee you one thing. It does get somewhat easier as you go, because as you put pieces together, there are fewer pieces to have to choose from. So it gets easier to decide as your sumo bot starts to take shape. Smart Kids Robotics, we had 2 bots in the ring at Sumo Advanced.
No. Yeah, let's go.
Why is his better at head to head?
Yeah.
Why is his better at head to head?
All right, bots to the ring. Who do we have here?
Okay, so now we have the Dominator versus Stomp. Back to back. Here we go.
Oh no.
Oh,
Oh shoot, thank you. Yes.
Oh!
This is a good dance. Like,
I got a new one.
oh yeah.
Stomp in the ring.
Oh yeah. Smart Kids Robotics, I have programmed my robot to go through this maze, not touch any walls, and mostly at least have one part of the robot touching the line at all times.
Sounds good. Hey, nice work. Well done.
It's okay. It could be better. It could be better.
Coming in the final turn. Hey, nice work. Good job.
Smart Kids Robotics, I made a robot that will make you go back, turn around, go forward, and then show us that's out of gas.
Cool.
Observe.
Hit pause in every zone. Nice. And it showed. Nice. Good work. Well done. Cool.
It works. It works. You got it. Yes. Yes. Wait. You look around in the back. Okay.
Wait.
I think we can
Look at that, look at that, look at that, look at that.
Yeah! That's a lot.
Alright, so here at Smart Kids Robotics we have Dominator versus Stomper. Okay, ready? 3, 2, 1, go.
A little back and forth. The round goes to Dominator.
Let's go. Okay.
Oh, off the edge. First matchup goes to Flappy Bird.
Alright, so at Smart Kids Robotics, I have been exploring the NXT interface by creating a line following program that will hopefully draw a rectangle around this keyboard and get back to its start. Let's see if it works.
All right. Hey, nice. And that was a tight rectangle. Good job. Looks good.
Give me a good one. Arm 09. That makes zero sense. But I'll try it.
What's the hardest part of coding this program? What do you think, Dominic?
The what is
Probably having to know what every single variable, like all of the 14 variables do.
There's 15.
So you have that many variables in your program?
Like 14 or 15.
Wow, that's
Yes.
cool.
And the whole is not.
Hey, good job. One. All right, let's see your hopper.
That's really
So, is it gonna stop at some point?
Yep. Yay!
At Smart Kids Robotics, I programmed my robot to go close to the wall but stop.
Using which sensor?
Using the ultrasonic sensor.
All right, cool. Oh, that's very cool. Now, I have a question for you right now. I'm gonna give you a surprise question. I want you to launch that same program, but twice as close to the wall. So start it from about right here, point it straight to the wall, and see what happens.
Okay, yeah.
Hey, so a shorter distance. So how did that work?
Because the distance, it doesn't matter the distance, it's just gonna stop at how many centimeters I put it to the wall.
And what's measuring those centimeters?
This, the ultrasonic sensor.
Perfect. Hey, nice job. Well done. Cool. Easier to add the extension after you have some build practice?
Yes.
Cool.
Oh, I got it.
No, I'm not gonna put that one. Put that one. Yeah, I'm gonna put that one.
Got some solid looking code there. Cool. We have Hajime versus the Creeper.
I got under it.
First match to the Creeper.
What? Something went wrong. Something went wrong.
First matchup to Hajime. Flappy Birdie versus Hajime. Oh, oh, oh! Nice work.
Yo!
Oh, that was sneaky. Warning versus Hajime 2.0. Go! Oh, fierce. That was a fierce start.
I added that.
That was
little bit of trickery.
unforgiving.
Something like this. Alright, this is it. Yeah. Oh yeah, that's it.
Intersection to intersection.
Can I make it like,
I survived! Woo!
And it dove across the zone. That was kind of dramatic.
It was.
I'm looking at the amount of code that you have in your program.
Oh, points. 400 seconds.
Wow, in the first few
Yeah.
hours
Oh.
at Smart Kids Robotics. Look how big that program is already. Can you scroll over and show us how much code you have there?
Me?
Yeah.
Oh, 1 sec. Oh, wait. I need to wait one out.
You have a change to make?
Yeah. Good job. Alright, download. Okay. Now we'll have a dark if I lose it. Alright, ready? No, okay, now.
So you built these hoppers, and you have them hopping. We've seen them hop across the floor. What might you change to increase the amount of movement every time the hopper hops?
A moving block. A motion block.
That's true.
Dang it, right?
And as far as the build goes, I see a couple extra pieces at your workstation. How might you be able to use those pieces to change how your hopper hops?
I don't know.
If you had to experiment with those pieces, how do you think you might use them?
Maybe just replace them for another piece in it.
I think you're off to a good start.
What should we
Finally, back to normal.
We have Bob versus Hajime 2.0 at Smart Kids Robotics.
Go!
Oh, almost. Matchup goes to Bob. Face to face goes to Child Hazard.
Go! There we go.
Matchup goes to Bob.
At Smart Kids Robotics, I made this robot to go around my table, my workstation, and come back how it started. So,
Pretty quick.
yeah.
It's looking good. Oh, nice. Hey, well done. Good job.
In Smart Kids Robotics, I programmed my robot to go in a square rectangle around my work desk.
Cool. Hey, that's awesome. Oh, cool. And the celebration at the end?
In Smart Kids Robotics, I designed this robot to make one full rotation around the board and one backward rotation around.
All right, cool. And both of those are in the same program?
Yes.
Cool. All right. All right, you started? Hey, that looks good. I like that sound effect too. Nice. Very cool, very cool. Good job.
At Smart Kids Robotics, I created my robot to follow the line, stop at the intersection, come around, come back.
Nice.
Intersection 1 versus intersection 1.
How's it going to know when it has found intersection number 2?
Because I use that logic and math to code it.
And I heard it say 2. Nice job.
Yeah!
Nice.
Go!
Now. Okay. I know what I'm missing.
And sometimes sumo bots start to square dance.
It's more like rectangle dancing.
What will the outcome be? Ooh, catches him from the back and forth, moving the motor. Oh! Reverse!
Oh, good job, man. You got my new.
Well done. 2. All right. Coded to navigate a maze. So it seems like left-hand turns are a little bit more challenging than right-hand turns. Nice job. All right. So it's all the way to the finish.
So now I'm going to be doing the maze backwards.
With the same program?
Yep.
Okay. So it's essentially a different maze if you're going backwards, right?
Yeah, I'm going to start in 3, 2, 1.
Look at that. All the way back to where you started.
Touchdown.
Hey, congratulations. Cool. Nice work. How is this, the tool that you've added to your robot, how is that going to be used to rescue the person at this point in the mission?
Well, it'll go like this. It'll reach the point to where it's about this far,
Okay.
and then it'll scoop up. And then this thing right here will block it. There's one on each side. So then it won't interfere with this.
The ultrasonic sensor. Good. Okay. How did you come up with that design?
Popped in my brain.
All right. Because you didn't have any instructions.
No, sadly not.
Hey. All right. Well, good work. It's looking good.
Like on number 2, it does that, stops.
And then
But the problem is, it goes straight to. It's not straight, so it never. It doesn't.
Now I
work.
wonder if this will work now. Bye.
Oh, so close.
At Smart Kids Robotics, I program my robot to make a figure eight.
Excellent. Hey, congratulations. Nice work.
It's fun.
So Yash, what do you think the most challenging part is of adding on a tool there to your sumo bot?
Figuring out what parts I need to connect because because to make it stable, it's going to be a little bit hard to connect certain pieces to certain places. And I think I just found which piece needs to go there. Oh yeah, that was fun.
Cool. It's looking good. Do you think is the hardest part about customizing your robot here?
Probably redoing all your code to make it take the tool.
That's a good point, because you change the tool, then you're changing the function, right? And sometimes sumo bots start to square dance.
It's more like rectangle dancing.
What will the outcome be?
Go!
Go! Both bots moving. Oh, it's close. Oh, they turned and faced off there. Match to match. Ooh, catches him from back and forth, moving the motor. Oh, reverse.
Oh, good job, man. You got my new.
Well done. In 3, 2, 1.
Go!
Our turn to each other.
I'm dead.
I'm underneath.
Oh.
Anybody touch it?
No, I'm dead. He is